The Earth is also known as the water planet. Although 1.4 billion cubic kilometers of water exist on the Earth, only 0.01% of it can be used by humans. Therefore, the rich natural water resources that surround us must be protected. One of FujiClean's missions is to protect and maintain vital water resources for future generations. Through focused and demanding research and development efforts, FujiClean strives for continuous product improvement and innovation on its already high-quality product line. This quality is reflected throughout over 30 sales offices, 3 factories, and 1 research laboratory in Japan. R&D for wastewater treatment systems focuses on enhancing environmental compatibility, such as by minimizing system footprint size, minimizing energy consumption, and maximizing advanced treatment performance. It takes a team effort to produce such quality. At FujiClean, we place a high value on our world-class engineering team and the many field-proven, proprietary, cutting-edge technologies and products it has developed, such as the innovative CE model technology. The FujiClean CE model line extends from small residential to commercial systems. Though different in size and flow capacity, all CE models share a common structure and process functions. We will now describe the system structure and function within a CE model system. First, raw wastewater flows into the first chamber, which is called the sedimentation chamber, which serves the septic tank. From there, the flow opening into the second chamber, the anaerobic chamber, is positioned at an intermediate water depth, resulting in horizontal water flow. This minimizes accumulated sludge from raising at the bottom of sedimentation chamber during peak flow hours. In the anaerobic chamber, anaerobic bacteria decompose nitrogen oxides into nitrogen gas. The wastewater flow train in the anaerobic chamber of the CE model also requires upflow through specialized media, which promotes suspended solids removal through enhanced settling and physical filtration. In the aerobic chamber, water flows through 2 different types of proprietary plastic media for decomposition and removal of organic matter and suspended solids. Concurrently, ammonia nitrogen is removed during the nitrification process. In the final stages of cleaning, treated water flows into the clarification chamber, where it is then transferred to the disinfection chamber for sterilization by the airlift control unit before final discharge. The CE model has built-in flow equalization to accommodate large influent fluctuations and flow variability. Due to this feature, flow levels in the treatment zone fluctuate by 50 millimeters. Next, we will cover system installation. The subsurface unit is typically installed on a level concrete base, which prevents damage from unequal ground settling or even earthquake damage. We recommend sand backfill and tamp lifts to prevent tank damage and to maximize support by form-fitting to the contour of the tank. The CE systems are designed for subsurface installation only. Access into the unit for maintenance is provided through access ports at grade level. The CE system requires a service check at startup and regularly scheduled maintenance once every 4 to 6 months after startup. Sludge pump-out is required at least once every 1 to 3 years, depending on the usage. A typical maintenance inspection starts with a check for odors, bugs, vibration, noise, and foreign objects. If an odor exists, or the transparency of treated water is 20 centimeters or less, additional analytics are required to troubleshoot the problem, which include water temperature, water transparency, an analysis of pH and dissolved oxygen for each chamber. Next, each chamber is carefully inspected. When inspecting the sedimentation and anaerobic chambers, check for abnormal increases in the water level, formation of scum, gas, and accumulated sludge. For the aerobic chamber, check for abnormal increases in the water level, aeration, and foam formation. Also check the recirculation flow level and disinfectant tablet volume. If large amounts of scum and accumulated sludge are found in these chambers, they are transferred back to the sedimentation chamber. Non-uniform flow, also called a short circuit in the anaerobic chamber, may be caused by a high concentration of suspended solids. This condition is remedied by the standard maintenance process of degassing by prodding the anaerobic filtration media lightly with a pipe. Next, check the bubble pattern in the aeration chamber. If there are no bubbles in the aeration chamber or bubble distribution is unequal, check for air leakage in the aeration pipe, inspect the blower and fittings, brush clean the aeration pipe, and adjust the aeration valve. It is essential to conduct a manual backwash in the aerobic chamber at every system inspection. Here is how this is accomplished. First, set the effluent valve to 0. Then set the recirculation valve to 70 to 80%, which will vacuum accumulated sludge from the bottom. After 1 minute, return the recirculation valve to its original position. As long as the returned water is still dark, continue to return water to the sedimentation chamber. Rotate the aeration valve to the right 100%. Conduct backwash for approximately 1 minute. Rotate the aeration valve in the opposite direction to 100%. Conduct backwash for approximately 1 minute. Return the aeration valve to the original position. Set the recirculation valve to 70 to 80%. After 1 minute, return the recirculation valve to the original position. Repeat this series of valve operations. The media has high trapping performance, and a single backwash is not enough to wash away excess biofilm from the media. Therefore, multiple backwashes are more efficient to detach excess biofilm and make them fall down to the bottom. Also, it is more efficient to conduct the multiple sludge returning operation rather than a single long operation. This is because the biofilm will be easily washed away and will fall to the bottom, and the biofilm will be pumped up by the airlift control unit. Please note that the backwash and sludge returning are one series of operations. After finishing the backwash operation, return the effluent valve to the original position. Check the status of aeration. Make sure to measure the recirculation water flow rate at the outlet of the recirculation pipe after adjusting water flow rate under the standard line. Before measuring the recirculation flow rate, please ensure that the water level is at the lowest operating level, as defined by the low water mark. Here are some troubleshooting diagnostics for some of the most common service issues. First, ensure that the water level is at its lowest operating level, as designated by the low water mark, since the water depth during normal operation may rise to a level 50 millimeters higher than this mark. To do this, turn the effluent valve to 70 to 80% until the water level decreases to the low water level. Recirculation rate is an important tool to evaluate how well the system is operating. Once the water reaches the low water level, return the effluent valve to the original position and measure the recirculation rate. If the discharge effluent water volume does not increase by turning the effluent valve to 70 to 80%, inspect and clean inside the effluent airlift pipe with a brush. If the recirculation rate is too low, then try cleaning inside the recirculation airlift pipe and recirculation pipe with a brush. An inspection of the aeration chambers is another good tool to evaluate a system. Evaluate bubble strength in each zone of the aeration chamber. If bubble development is unequal, even after the manual flushback procedure, then air lines must be cleaned. For airline pressure water cleaning, fittings are provided for secure water line connection to the union of the aeration pipe. A pipe cleaner inside the aeration pipe is an alternative method for cleaning aeration pipes. In commercial systems, the effluent valve and recirculation valve are located above the clarification chamber. Recirculation flow rate is measured using calibration marks in the flow regulation box. During flow rate measurement, the return gate of the regulation box should be closed. After backwashing by the aeration valve, do the backwash by a backwash valve and a backwash distribution valve. These valves are used to clean both zones within the aerobic chamber of the system. Air pressure is controlled manually and alternately concentrated on one zone and then the other. Please ensure the backwash valve is closed after the backwash procedure. If foam in the aerobic zone rises to a depth where it spills over the anaerobic chamber partition, the biotreatment process may need a boost with seeding material placed in the aerobic chamber or anaerobic chamber. If scum is found in the clarification chamber, transfer it manually back to the sedimentation chamber. If you find a mass of biofilm on the wall of the tank, remove it manually with a brush or cleaning tool. If you find accumulated sludge in the clarification chamber, ensure that the recirculation airlift pump is functioning properly, transferring sludge and processed water back to the sedimentation chamber. If no water is being pumped up through the discharge airlift pump while water level is above the low water level line, then using a cleaning brush, clear any clogs in the effluent airlift pipe. Also clear any possible clogs in the effluent valve itself by opening and closing the valve several times at every inspection. System controls and alarms are designed to meet the specific needs of the project or to meet all regulatory requirements. We require a prompt service response with any system in an alarm condition. Failure to respond in a timely manner only increases the likelihood of compounded problems such as odors. If a blower problem is responsible for the alarm, replace the blower diaphragms, which are supplied in a blower rebuild kit, followed by a resetting of the auto stop switch. When sludge accumulation reaches pre-identified depth levels in the sedimentation anaerobic chambers, sludge pump out is required. In this operation, it is important to pump the anaerobic chamber first, starting with scum from the upper layer, followed by sludge in the bottom. After the anaerobic chamber is pumped, then the sedimentation chamber follows. Pump out in this order prevents scum from clogging the anaerobic media, which could occur if sedimentation chamber is pumped first. We recommend a complete manual backwash procedure to prepare the anaerobic chamber before pump out. Thorough and careful service maintenance is essential to ensure long-lasting, optimal performance of the FujiClean treatment system.